Hello, Mr. Westwater here, and I'm going to take you through another quick video, this time on how to multiply decimals together. Okay, so when we're multiplying decimals, I generally split it into 4 steps. So first, we're going to think about the multiplication without any decimals in it. So if it's 2.1, we'll think about that as 21, for example. And we're just going to multiply it those numbers together in the way we would normally. So if I have something like 2.1 times 3, I would just think about this as 21 times 3, which, you know, in this particular case we can do in our heads is 63. Okay, so that's our first step. And the key thing is I'm not going to simplify my final answer yet. And this is quite an important step, but I'll talk about it in a little bit more detail once I finish going through the examples, and hopefully you'll see why I'm emphasizing that. Okay. Then we count the number of decimals in our original question. So let's keep that 2.1 times 3 up, and we're thinking about this as 21 times 3, which we said was 63. So I'm going to count the number of decimals in the original question. Now in this particular example I've just got 1, okay, and then step 3, place the decimal back into my final answer that many places to the left of the final digit. So the 3 is my final digit. In my question there was only 1 decimal, so I'm just going to place the decimal 1 to the left of that 3. So 2.1 times 3 in this particular case is 6.3. Okay, and I've also got a final step in here because I think in mathematics it's unlike any other subject. We have the opportunity to sort of check our answer and see if we're right before handing in our work. So let's check our answer with a quick estimation. So in this particular question I had 2.1 times 3, well 2.1 is roughly equal to 2, and 2 times 3 we should all know is 6, so I'm quite happy. 6.3 is quite close to 6, so that gives me confidence in my answer. As long as it's fairly close, you should be able to take a lot of confidence from your answer. If it's out by a factor of 10, so if I kept it at 63, or if I put an extra decimal in, had 0.63, that would show a few concerns. Okay, but as long as it's roughly around that ballpark figure and you don't need to multiply or divide by 10, that should give you confidence in your answer. Okay, so those are the steps we're going to use. Let's get straight into some questions. So here we've got 21 times 2.7. So step 1, I'm just going to think about this as 21 times 27. Okay, and I like to use the traditional sort of long multiplication method, but other methods are available. So I'm going to start by doing 1 times 7, writing it here, and then 7 times 2, which is 14, and I'll carry the 1 over into my hundreds column, then add a 0 as I'm going into the tens column, and 2 times 1 is 2, and 2 times 2 is 4. So my final answer is 7, 6, 5. Okay, that's what I would get if I did 21 times 27, but I'm doing 21 times 2.7. So the next step, how many decimals are there in the question? Well, there's only 1. So I'm going to go 1 jump in from that last digit. Okay, so my final answer is going to have the decimal here. My final answer is 56.7. But wait, it's not my final answer. I need to sort of sense check this a little bit. So let's do a little bit of an estimation. So 21 is roughly 20. 2.7, well that's roughly 3, isn't it? Which is 60. So are these quite close? Yeah, they're quite close. So that gives me confidence that my final answer is correct. Okay. Let's have a look at example 2. I have 3.4 times 7.7. So again, think about this without the decimals there. So 3.4, I'm just going to write as 34 times 77. Okay, so again, 7 times 4 is 28, and I'll carry 2 over, and 7 times 3 is 21, but carry that 2. Okay, move into your tens column, so add a 0. 7 times 4 again is 28, and 7 times 3 is 21 again, so again carry the 2. Okay, and add these together, so 8, and then we've got 11 here, so 1, carry 1. 2 and 3 is 5, so we've got 6, and then 2. 2,618. But wait, we need to count how many decimals we've got in our question. We've got 1, 2. Okay, I know there are further decimals after there. We could have an infinite amount of zeros, but we just used 7 and 7. We didn't times it by 770, for example, so we're only just going to count these decimals that I've highlighted. Okay, so there are 2 decimals, which means I need to go 2 places from the right. My new decimal is going to go after that 6. So my final answer is 26.18. And again, let's do a quick estimation. 3.4 is roughly 3. It's roughly 3.5, but hopefully we'll be okay. And 7.7, well, that would round up to 8. So let's think about 3 times 8. Well, that's 24. Well, that's very close to 26. So again, it gives me confidence in my final answer. Okay, now final example. 8.36 times 0.85. Okay, so again, think about this without the decimals in. 8.36 times, without the decimals in, 836 times 85. Okay, I always generally write the smaller number on the bottom, just it reduces the amount of rows you have to do when you do the long multiplication. Okay, so we're going to start off with a 5 times a 6, so that's 30. I'll carry the 3. Then we've got 5 times 3, which is 15, carry the 3 from before, is 18. And then 5 times 8 is 40, carry the 1 from before, 41. Okay, now let's move on to the 8s. So remember, this is the tens column, so I've got to add a 0 here. And 8 times 6 is 48. Let's put an 8 and carry the 4. 8 times 3 is 24. So this will be 28, carry the 2. And 8 times 8 is 64. Add the 2, 66. Okay, so altogether, we've got 0, 6, carry 1, 10, so carry 1 again, 11, carry 1 again, and 7. Okay, so how many decimals are there in the question? We've got 1, 2, 3, 4. So my answer is going to take the decimal from the far right. Now, we do need to be careful, and this is why I say don't simplify it yet, because if I started thinking about this as a decimal number, 7106, and I knew the decimal was somewhere, I wouldn't actually write that 0 in at the very end. I just leave it as 7106, because you don't, if the decimal's here, then that 0 doesn't add anything to it. So we need to make sure we don't simplify it first, because that 0 is important, okay? Because it's going to add an extra place value to this calculation. So I'm moving 1, 2, 3, 4 places in, okay? And my decimal will go there, okay? Now, we would simplify the answer now, so this would be 7.106. I wouldn't include the 0 in my final answer, but it's important we didn't think about that first, we thought about it afterwards. Okay, and let's just check this answer. So I've got a value of 8.36, which is roughly equal to 8. And I'm timesing it by something that's close to 1. So my answer is going to be around about 8. It's going to be slightly less than 8 because this number's less than 1, so it's going to reduce it. And my final answer is 7.106, so I am quite confident that that answer works well. Okay. If you're wondering why this works, and why we're sort of taking decimals out and then putting them back in, well, what we're actually doing in all of these is we're multiplying this whole thing by a power of 10 to remove the decimal. So 8.36 has been times by 100, and 0.85 has been times by 100. So in my final answer, I need to divide by that 100 twice, which is why we end up moving 4 spaces from that final answer. Okay, I hope you found that helpful. Of course, there are other ways to go about the multiplication, but the general process will always be the same. Okay.